Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, we'll discuss numericals on gravitation. Let us start with question number 1 of the numericals. So let us start question number 1, numerical. Students, let us solve numericals. In this chapter, gravitation, we have a few formulas that we'll quickly write down. The expression for G is Gm over r square. At any height h, it is Gm over r square. It also can be written as G r over r plus h the whole square. Just we'll quickly write down the formula, then we will solve the numerical. Then we have acceleration due to gravity inside the surface of the earth. Gd is given by g into 1 minus d over r. Then we have g lambda, that is our latitude, g minus omega square r cos square lambda. Fifth, the critical velocity under root gm over r, or critical velocity is gr. Next we have escape velocity, which is root 2 times the orbital velocity or critical velocity. The binding energy is gmm over 2r for moving object, and gmm over r for stationary object. The time period of satellite square of the time period is proportional to r cube. The time period is 2 pi over under root gm, and r to the power 3 by 2. So these are the expressions and the formula. Now we have to solve for the numericals. First numerical, I'll just explain the question to you. That there is a body, it weighs 4.5 kg weight on the surface of the earth. So when this is placed on the surface of the planet, its weight is this one. This is suppose planet X. The same mass is taken and kept in another planet. How on the planet whose mass, here the mass of this planet X, that is mass of planet X. This is suppose planet Y. This is the mass of planet Y. The question is given that the mass of the planet Y is 19 times the mass of the planet X, and mass of the radius of this planet Y is half the radius of the planet X. Then if this object is placed on this object, on this planet, its weight here is suppose something like that, W1. What will be its weight here? That is the question. So just let me explain the questions once again, then solve. There are two planets. This planet is given in the question as planet Earth. if one of them happens to be Earth, then the object placed on the surface of the Earth weighs 4.5 kg weight. So you can see that the kg weight is it should be, we could convert that into Newton if you want. 1 kg weight is 9.8 Newton, or approximately 10 Newton. So if I say how much weight, then this is 45 Newton, or in case of kg weight also you can write 4.5, no problem with that. If the same object is placed on a planet whose mass is 1/9 that of Earth and radius is half that of Earth, then here how much will be its weight, because the weight depends on the mass and the radius of the planet. Because the weight, when you talk about weight is mass into acceleration due to gravity. So when you talk about the weight of this, then the acceleration due to gravity of that planet has to be considered, because this mass will remain same here or here, but weight will not remain same. Here g Earth, here gy. So that will be the change in the weight. Here suppose this is W1 and here it is W2, we want W2. So what I'll do, the weight on the second, that is second planet, is mass of the object into g on the second planet, that is y planet. Weight on the first planet is mass and the g on that planet, that is Earth. If I divide these two, the mass will cancel out, and W2 weight on the that is W1 gy by g Earth. That means basically we have to relate the g value, and then the g is gm over r square, that all of us know. The small r becomes capital R because the object is on the surface of the Earth, h value is 0. Gm over r square. From here g is constant for both the planets, the planet Earth and the planet y, or whatever is that. G is same to both. Mass will change, r will change. If I consider this mass as m, then it is 9 times 1/9 of that, so m by 9. If its radius is, I consider r, its radius will be r by 2, that is given in the question, half of that. So this formula W1 into gy, for this one g will be there, m is m by 9, gm over r square means square of this, that is r by 2 the whole square, divide by g is again gm, m is mass of the first planet, this one is m, and r square is that one. If I solve this, then what I will get, W1, g will cancel out, that m will cancel out, r square will also cancel out, this is 1 by 9, this is 4 goes off, this is 4 by 9, so W2 is 4 by 9 times W1, and the W1 was 4.5 in terms of kg weight into 4 divided by 9, so this answer also will be in kg weight. 4.5 2s are 9 and 2 2s are 4, so answer comes out to be 2 kg weight. That means the object which is placed, when it is placed on another planet whose mass is 1/9 mass of the planet and radius is half that of Earth, there the weight will come out to be 2 kg weight. So that is the answer to this question. Thank you.